going to discuss the nodal method of analysis for circuits with the voltage sources. Nodal method is an application of KCL. It deals with the nodal voltages as variables instead of branch current or branch voltages. For n node circuit, there will be maximum n minus 1 nodal equations because one of the node is treated as a reference node. The procedure is simple, that we have to identify the nodes, select one of the node as a reference node. We will be assigning the unknown node voltages to the remaining n minus 1 nodal nodes, and the equation is written for each of these n minus 1 nodes, keeping the outward current as positive. This outward current as positive is needed to, you can say it is in line with the Ohm's law, where the current flows from the higher potential to the lower potential. Now these equations are solved to find out the unknown node voltages, and thereafter the other parameters are calculated. So this particular is a recap how the equations are to be written. This we have gone through previously. Only thing which is to be highlighted, that one of the node is to be taken as a reference one, and the outward current has to be taken while say we are writing the equation for individual nodes. So for say first node, this particular, the whatever say is marked in the red, that particular is the reference direction, where say for the second node, these are the reference direction marks with the blue sign will be the reference direction. Now this is a generalized form which we obtained when say the circuit is having only the current sources. This particular is also we obtained when say the circuits are having independent voltage sources. So some sort of this arrangement we can work out, only thing the interpretation will change. Now there are say the different cases. Circuit with only current source we have covered in the last. In this, the cases are classified into the 4 categories, where say the ideal voltage source between a node and reference node is present, that particular is one case. Practical voltage source between node and reference node. So the practical means it is coming out to be a series resistance with a ideal source. So that is adding to the practical source. Now third particular is a practical voltage source between the two non-reference nodes. So this particular is a different case from the previous one. And lastly, ideal voltage source between two non-reference nodes. So this particular is a special case, and that particular is regarded as a case of supernode. This we will also be discussing in this particular discussion. So as a recap, after say the recap, we are simply considering all 4 cases one by one. So here say the ideal voltage source between a node and a reference. So let's say this particular, the V2 is having a direct voltage which is specified. So as the intention of the nodal analysis is to find out the unknown node voltages with respect to the reference. So when say this particular voltage is already known, there is no need to write the nodal equation for this particular node, where say there is a voltage source directly between the node and the reference one. So here say the point is clear, the V2 is known, there is no need to write the equation. So we will be dealing with the reduced number of equations. These particular equations are to be written the way has been discussed previously. So this is for the node 1, this is for the node 3. Here say the voltage V2 is participating likewise. So that particular is already specified. So that is a 4 volt. So ultimately we will be coming out with the reduced number of equations. When say there is a practical voltage source, so practical voltage source is represented as a series combination of ideal voltage source and a series resistance. So this particular has to be understood. Now just to illustrate this particular point, when say this V2 is a voltage with respect to the reference, this particular is 4 volt. So what will be the voltage across this 5 ohm resistance? So that particular is V2 minus 4 upon 5. So that will be the current, and the voltage across this will be V2 minus 4 volt. So that is deriving the current. So this rider, this consideration we have to account, and there is no special treatment for this particular network. We have to write the nodal equations for all the nodes because the voltage V2 in this case is still unknown. So we will be writing the equations likewise. Node 1 and node 3, they are not changed as such. So nodal equation for node 2 is going to be affected by this change. So that particular is simply substituted likewise, this particular term V2 minus 4 upon 5. So now next particular case, in this the practical voltage source between the two non-reference nodes. So you please the same circuit with a modification. Here say the two non-reference nodes, node 3 and node 2. There is a practical voltage source having a 5 volt as a supply and the 8 ohm as a internal resistance that is connected. So what we will be seeing, that this particular is having a connection with the third node, this particular is also connected to the second node. So these two equations are going to be modified. Now the same principle which we have to apply, what will be the current through this 8 ohm resistance. So if suppose you are writing the equation for node 2, this particular V2 is to be taken as a higher voltage, 5 volt is opposing it, so V3 is opposing. So ultimately it will be resulting into V2 minus V3 minus 5 upon 8. So that particular will be the current. Similarly, while you are writing the nodal equation for third node, so the current will be governed by the relation likewise, because ultimately V2 will be opposing the series combination of V3 and the 5 volt. So likewise you are able to write down the equation. These two terms, these two equations are there and they are highlighted with a different color as well. Now this particular is a concept of supernode which is a special one, and this question arises when say there is a presence of ideal voltage source between two non-reference nodes. So how we have to solve it? So this is one case where say the voltage source is indicated in this diagram. Another is if suppose say there is a voltage source and there is a parallel arrangement. So that particular is also to be taken as a supernode. So how it is defined? A supernode is formed by enclosing ideal voltage source between two non-reference nodes and any other element connected in parallel with it. So now we are dealing with the nodal analysis as such. So when say that there is a name of supernode, it comes that it has to have a unknown voltage, but it is not the case. This particular is not having any voltage on its own. So that is to be clarified. We have to still deal with the V2 and V3 in this case, or you can say the previously assigned node voltages. However, these two voltages are defined, are related by a constraint relation, or you can say another equation. So in this particular case, what we will be seeing, V2 is equal to V3 plus 5 volt. So that particular relation is dictated by a KVL relationship and so on. Now how we have to solve? If suppose say we are not dealing this as a supernode, that particular, if suppose say you are writing the nodal equation here at V2, so you will be considering this as a outgoing current, this as a outgoing current, but here say it is a voltage source, so you have to assign a new variable which is IA, let's say. When you are writing this, that is to be assigned another IA. So you will be dealing with another unknown which is the IA, and it basically is going to add the equations. So instead of this, the process is a supernode is identified and we will be writing the KCL equation at the supernodes, keeping the outgoing current as positive and the outgoing current is to be calculated from the previously assigned node voltages. So in this particular case it is V2 minus V1 upon 2. Here say it is V2 upon 4. In this particular outgoing V3 minus V1 upon 4. This particular is inward current, so it is appearing with the negative sign. So ultimately this is one equation. Another equation that is pertaining to the other node. So basically in the supernodes the number of KCL equations are getting reduced. However, as you can see that there are say 3 unknowns V1, V2, V3. So it is having 2 KCL equations, and the third one, that is the KVL equation which we discussed previously, that has been referred as a constraint. So these particular are forming a set of equations to solve ultimately this. So here says because of the substitution the relationship is coming out to be like this. Now with this background we can go for a few numerical examples based on the supernodes. So in this particular example we have to find the node voltage. There is a direct voltage between V1 and V2 and there is a parallel resistance across it as well. So these all are forming the supernode. So now the equations are, the concept are clear, that you have to write the KCL equation which is the nodal equation pertaining to the supernode, and you have to also write the constraint equation pertaining to the voltage. So what is the constraint equation in this? V1 plus 2 is equal to V2. So this particular is a constraint equation. This you can rewrite into the different form, V1 minus V2 is equal to minus 2. Now we have to write the KCL equation. So corresponding to this supernode, this will be the outgoing current V1 upon 2. This particular will be the outgoing current V2 upon 4. This is a inward current, so minus 2. This particular is outward current, so plus 7. So it is ultimately resulting into the equation like this. Point which is to be clarified, how this parallel resistance is participating in the supernodes. So you please be mindful, if suppose say you are writing the outward current here, it will be V1 minus V2 upon 10. Correspondingly here the outward will be V2 minus V1 upon 10. So both are of opposite polarity and they will get cancelled out. So that's why the parallel combination across this voltage is not basically counted separately but is taken with the supernodes. Now this particular is also a case of supernode example. Here say V1 is related with the V2, V2 is related with the V3. This is also a voltage source, although it is a controlled source, but there is no series resistance. So this is a ideal controlled source. This particular will be able to maintain the voltage as long as the value of I is unchanged. Likewise, so this whole is treated as a combination of supernodes. 6 ohm is participating on this as a parallel. So this is forming the supernode. Ultimately you will be dealing with only one KCL equation, that particular is V1 upon 2 plus V2 upon 4 plus V3 upon 3 is equal to 0. However, to solve it you are having the constraint relationship. Likewise, V1 is equal to V2 plus 10 volt, that particular is one relationship. Third particular relationship, V2 plus 5I is equal to V3 and so on. So these particular are there. Now this is a controlling current I. This is depending on the only this particular node voltage V1 likewise, and we can solve it conveniently. Now as a summary, it is already known that this is an application of KCL. Nodal analysis is an application of KCL. In the case of supernode arise only when ideal independent or dependent voltage source is present between two non-reference nodes. So here say the sense of ideal means it is only a voltage source without any series resistance. Supernode does not have a voltage of on its own, but it is forming a constant KVL relation between the two nodes. There is no need to write the nodal equations for nodes with an ideal voltage source connected between the nodes and the reference. So these are, you can say, the summary. Next we will be dealing the mass analysis, which is the another analytical method, and these are the textbooks suggested for further reading.